Hello everyone, I hope you all are doing well and having a good week so far. This video is just designed to kind of give you a little bit of an update on what you can do for your statistical analysis for CAP 6 as well as with the class project. Now, one of the parts or kind of the main purposes of this class project is to kind of walk you through a little bit of kind of each part of a journal article. So far you've already written your introduction, many of you have written your methodology sections, and now we're at kind of the results section. And probably as you were reading some of these results sections back for CAP 2 when you're doing your annotated bibliography, chances are you're probably pretty confused as you're kind of reading through those results sections. They're very heavy with statistical jargon, lots of numbers, and it's hard to know kind of what it all means. And so that presents a challenge for us in this class because we're trying to kind of introduce you to the idea of kind of what these parts of a journal article are. But I know also that many of you don't have a very strong background in statistics, and the textbook only covers a small number of statistical analyses that we can really work with. And so I can make it difficult at times trying to apply that to the class project because some of the more appropriate analysis that we could use for these kind of research questions like repeated measures ANOVA or an ANCOVA or kind of all these different things that require things like covariates and interactions is really hard to try to condense that into something that's easy to understand when you don't have a big, strong background in statistics. And so the main test that we can use then, based on what we've done so far in this class, is a simple paired t-test. However, a lot of you with your research questions have kind of a pre and post design, and you're wanting to compare different groups. And the problem with a paired t-test is that it doesn't allow us to compare groups. We can look at change over time, but we don't have an easy way within a paired t-test to compare differences across different groups, like an experimental versus the control, or group 1 versus group 2. And so, like I said, that presents kind of a challenge for us in trying to kind of do this in a way that makes sense, especially with the tests that are available to us in the textbook. However, I did have a student earlier this week ask me a question about another type of analysis, what about he could do that while isn't something that we've covered in this class and is not in the textbook, it's actually really simple to do. And after thinking about it and talking with other professors about it, we feel like it would be a good option for many of you to kind of better get at your research question or what you're interested in testing for. And it requires really only one extra step that we haven't talked about, and then all you have to do is run an independent t-test. And that's it. So it's actually pretty simple to do, and so even though it hasn't been part of our class so far and it's not in the textbook, we feel like it's pretty easy to show you. So tonight what I'm going to do, I'm going to show you how you would run an analysis kind of with your fake data with a paired t-test first. That way you can kind of see what many people are doing or we've been trying to help them to do. And then I'm going to show you kind of this other way to do it, which is using kind of what's called a gain score analysis to kind of show you how you would run it differently. And honestly, I think for many of you, this gain score analysis is probably going to help you answer the question that you really want to know. And so it will kind of allow you to do that without having to have a lot of really in-depth statistical knowledge about things like the repeated measures or covariates or all that stuff that really you don't need to know for the purposes of this class. That's for stuff much later on, or if you want to go to grad school. So let's kind of dive in here for a second and let me try to show you, kind of walk you through these two different tests. The paired t-test, which many of you have done before already for assignment 3, and this new alternative that you can do called a gain score analysis. So the first one I'm going to do is the paired t-test, so you can see the differences first. So this data here, if you see on the screen, this is all fake data. I just made it up, just like you would do for your CAP 6 assignments. I have 10 people in my group 1 here. This is I've called it my experimental group. For your project, you might have a different name, but that's what you could use. And then I have 10 people here in my control group that I've called it. And I've got 5 males here and 5 females. And likewise, I have 5 males here and 5 females. I've included their age, height, and weight. I know the template from Blackboard uses centimeters and kilograms. I know inches and pounds, so I just switched those here to that. You can do that too if you want. It's not a big deal. But I have their height and weight listed for the fake data in both groups. And then for my outcome, I just chose deadlift for 1 repetition maximum. So a 1 RM for deadlift. And I have pre and post data for our experimental group, and I have pre and post data for deadlift in pounds, okay, so weight lifted in pounds for the control group. And then for my continuous data, so this right here, I have calculated means and standard deviations for these as well. Because remember, we can't do a mean or a standard deviation of gender, because that's a category. That doesn't make any sense. So I have that here as well for both groups. So let's say that I wanted to know what change occurred in each group over time from pre to post. Well, to do that, I could do a paired t-test. And so what I would do is I'm going to click here, this little button which you should have on your computer. This is the data analysis section that you should have downloaded for assignment 3 and for 1, possibly as well. So I'm going to click on this here, and I'm going to choose the t-test pair. So a paired t-test. Click OK, and this is where I'll be able to select my data. So the first one I'm going to do is for my experimental group right here. So I'm going to see, was there a statistically significant change for just the experimental group from their pre to their post for their deadlift weight that they lifted. So first thing I'm going to do is I'm going to click this right here. This will allow me to select my data. So I'm going to select here down. So for my experimental group in pre, that's going to be my variable 1. And then variable 2, I'm going to click this button right here. And I'm going to select right here, so the post for my experimental group. Okay, click again. I'm going to check labels because I included the label right here. So I've included that in my selection. So if you do that, you need to click the label. Alpha, I'm setting at 0.05. So if my p-value is less than 0.05, then it is statistically significant. And then you can choose where your output or where your results come out of. So what I do normally is I just click this little button here, and then I'm going to select that cell, and that's where my output's going to pop out. So press enter. Okay, now I have everything here. I'm going to click OK, and then boom, there's my results. One thing I'm going to do real quick, I'm just going to select this and then drag it up just so it's a little more together. Okay, so with this results, this tells me that the average or the mean deadlift weight was 176 pounds in the pre for the experimental group, and then in the post that rose or increased to 192.5. These are my variances. So if I were to square root both these numbers, that would give you my standard deviation. And then this is the result for the t-test, and we'll look at that stuff in more depth in a second. But for now, let's go ahead and run our paired t-test for our control group, and so we can get their results as well. So again, I'm going to click the data analysis button, paired t-test, click OK. I'm going to select my first variable, so I'm going to go here, and then my control group, select the pre-deadlift weight lifted scores, then go down to variable 2, click that button, click and drag these scores and the label, click that button, again, make sure that's checked, it is, alpha set at 0.05, I need to change my output range, so I click this button here, and I want my output to pop out in that cell right here. Gonna press enter. Okay, that's everything I need. So now I'm gonna run this next paired t-test, click OK. There's the results for the control group. So let me just click that and drag it up so it's all together. And right here, just to make it easier, I'm gonna type experimental. That way I know that's for the experimental group, and this is for the control. Okay, so let's look at the results here. So for our experimental group, okay, we have our t statistic right here of negative 6.9. In these cases, we know the direction that we're looking for. In most cases, we want to see the results improve or increase. If your outcome was something like body fat percentage, that would decrease, but then you'd still know the direction that you're expecting it. So in that case, because we know which way it should go, I'm going to look at the one-tailed thing here. And that's really small, but if you want to know what that is, I'm going to switch this. No, I know what I can do. To a number. Okay. There we go. So if you don't know how to read the scientific notation there, that tells us that our p-value is 0.0000, if you round that to 4. So that tells us that this p-value is smaller than our alpha. So that tells us that there is a statistically significant difference between the pre-score and the post-score, meaning kind of this number here and this number here. So the 192 is significantly higher than the 176. Because what we're doing is we're taking all the scores from the pre and getting an average. Getting all the scores from the post, getting an average. And then we're trying to test whether those two scores are statistically different from each other. In this case, they are. So we know that the post scores are significantly higher than the pre scores. And again, we know that because we're looking here at the p-value for a one-tailed test, and that number there is smaller than 0.05. So that would be what we expect. The experimental group, there should be a difference there, theoretically. I mean, obviously, this is fake data, so we can make that happen in this case. Because again, there's just not enough time to collect real data for the project. Okay, so now let's look at the control group. Because again, this test only tells us does the experimental group change from beginning to end. So let's look at the control group. In this case, for our control, we see that the pre-test deadlift weight on the average was 175. And then for the post, it decreased a little bit, but basically stayed the same, was at 174.5 pounds. So no real change there. In fact, it kind of went down a bit based on whatever control they were theoretically doing. But let's go ahead and look at our results. So we have here, this is our t-statistic, which is really small. It's 0.18. The back period was like 6.85, so this is a lot smaller. We look at our p-value right here for a one-tailed test, because we expect to know it should, or hopefully it should go in one direction. This is obviously much larger than 0.05. This is 0.4. So we know then, based on that there was not a statistically significant change from P to post for the control group, which again, that kind of makes sense. If it's control, it shouldn't change. Now, the main limitation of this is that these analyses won't tell you are the groups, or is the experimental significantly different? Is the control different from the experimental? It won't let us kind of compare groups. We can look at, within each group from pre to post, but we can't say, hey, is the experimental different from the control? And so there's a way then to try to do this in a different kind of simpler way that can let us do that. And again, it's not mentioned in the textbook. That's why I'm going to show you here. Before I get to that though, I'm going to show you an example of what the results are written like if you do two paired t-tests. So if you were to do this analysis that I just ran and you were to write it up, this is kind of what it would look like. So this first paragraph here, this is just my descriptive statistics. So let's start off right here. We have the participants in the experimental group ranged in age from 18 to 30 with an average age of 25.1 with a standard deviation of 4.2 and an average height of 66.4 inches plus or minus 4.3 and an average weight of 154.7 plus or minus 27 pounds. So where did I get all that information? Well, the age range, so I looked at the experimental group right here. Okay, I looked at these ranges. So 18 is the lowest right there, and 30 is the highest. The M_age, that's the mean age, 25.1, which I got right here. The plus or minus 4.2, that's your standard deviation, so kind of above and below. So in this case, that's the number where I got that one. And then I followed the same pattern for the rest of this. So average height of 66.4 plus or minus 4.3. Well, there's 66, there's 4.3, and it's the same thing for weight right here and right here. Following from there, likewise, the control group ranged in age from 19 to 32 with an average age of 25.3 plus or minus 3.9 with an average height of 66.3 plus or minus 4.5 and an average weight of 154.6 plus or minus 23.7. So in that very short amount of space, I included pretty much all the descriptive statistics for your fake data, which I just pulled from basically right there. Then the next section here is actually telling us the paired t-tests. So again, we have to run two separate t-tests here. So for the first one, A paired t-test was conducted to compare the pre and post performance of just the experimental mental group on 1RM deadlift. So I was just telling the reader what you did. And then you'll say, in this case, there was a statistically significant increase in 1RM scores from the beginning to the end of the study. So that's that pre and post. So I have the mean weight and standard deviation right here from the beginning of the experimental group, which I got from right here. Now, the standard deviation is 19.7. Well, that number isn't included in here, but if you remember from back in the early chapters, to get standard deviation, all you got to do is square root variance. So it's really simple. I'm going to type, click here, type in enter, and then SQRT for square root, open parentheses, click this first variance for the pre, type enter, and right there is standard deviation, okay, for the pre right there, which I pulled right there. And then to the end of the study, the average was 192.5, which I got from right there. Standard deviation is 22. So same basic idea. Enter SQRT, square root, select that number, push enter, and that is my standard deviation, which matches that number right there. And then this right here would be the results from your paired t-test. So to do this, all you do is just plug in numbers. So the T is for the t-test. The 9 comes from your degrees of freedom right here. You don't really know what that is at this point. Don't worry about it, but that's where you would get it from. Your T statistic goes right here, which I got from this cell right there. And then the p-value over here is less than 0.01. And all you would do is look at this cell right there. That's all you would do. And that's a really, really small number. So to identify that, you just put p is less than 0.001. That's the smallest that you will put in the text. And then for the next part is the next paired t-test. So I would say, in addition, a second paired t-test was conducted to compare the pre and post-test performance of the control group on 1RM deadlift. The next line then says, however, there was not a statistically significant increase in 1RM scores from the beginning to the end of the study. So again, now I'm looking at this table. So the beginning is the pre, and I have the mean of 175 right here. Standard deviation of 26.5. All I would do is square root this number right there. And the end of the study mean was 174.5, which I got from this cell. Standard deviation of 27.5. Again, all I do is square root that number like I did up here. And then this is the t-test results, which again, you just plug and place. So the 9 is degrees of freedom. 0.18 I got from right here. And then p equals 0.43 right there. And again, that's greater than 0.05, so it means the results are not significant. And then all I need is just an overall conclusive kind of a wrapping up sentence that says, these results indicate that only the experimental group experienced an increase in 1RM for deadlift. And with the paired t-test, that's all I can say. I cannot say that the experimental group was significantly higher than the control group or anything like that. So if you have an example where maybe you're not using a control, maybe you have kind of two different exercise regimens, and so one's not really a control. And let's say you found with a paired t-test that both of them significantly increased. Okay, well, great. But can you say either one is significantly higher than the other? You can't do that with a paired t-test. And that's one of the limitations with the tests that were given in the textbook. So the alternative that I'm about to present to you is a way that you can do that. And it only requires one test, and you just have to do one extra step in order to figure that out. Okay, so that's why there's a little bit of limitation with the paired t-tests, but this might be a different alternative that you can use instead. So I'm going to take my mouse cursor here. I'm going to click down here, this next Excel sheet. It says gain score. So I'm going to click on this. Okay, it is the exact same data as before. Okay, now nothing has changed. Okay, this is the exact same data. I'm going to maximize this real quick. Okay. Now, if you notice here, I have a new column here called a gain score. And what we're going to do is we're basically going to subtract the post-test scores from the pre-test scores. That's going to give us kind of this difference, or we're going to call a gain score. Now, that doesn't mean that scores will always increase. Depending on your variable, they could decrease. Like if you're using body fat percentage, you'd want to see that those scores would decrease over time. It's statistics, so unfortunately that's when they call things by weird names. So it is called a gain score, but it could, depending on your variable, it could go up or down. That doesn't matter. But then once you have your gain scores, then all you're going to do is then run an independent t-test on those gain scores. Because an independent t-test looks at analysis at one point in time. It can't look necessarily at pre and post data by itself, like in the raw form. So what we do is we get this gain score to say, hey, how much did this change? And we have a single value for it. Well, that allows us to then do a single independent t-test to look at the average, or was there a difference in the average change? Now, if it doesn't make a whole lot of sense, that's okay. Let me show you first, and hopefully it might make a little more sense. So let's look again at our experimental group. Okay, same thing, same data. So you're still using deadlift. So I'm going to click here in the cell. I'm going to type in the equal sign, start a formula. I'm going to take the post test score for this person in the experimental group. I'm going to subtract and then click on their pre-score. Okay, so this is basically saying let's take their post score, which is they lifted 210 pounds, and subtract it by 180 pounds, their pre-test score. Press enter. That tells us that from beginning to the end of the study, their deadlift score increased by 30 pounds. So that's this person's gain score. So I'm going to click this. I'm going to click this little button right here, like in that little square. I'm going to click and drag, and it's going to apply this formula all the way down. So click and drag, bring it down to here. I let go. Now it's basically has converted that formula all across the rest of them. So if I double click here, okay, this again shows me post minus weight equals 30. Same thing if I were to click on this one. So this is 15. Click on this. Okay, it is applied the formula that I did earlier to all these other cells. So we've got for this person, their post weight was 220, subtracting from their pre, which was 205. For this person, their gain score was 15. Okay, so I would do that for each person in the experimental. Then I come down to the control group. Now I'm doing the same thing. So I'll type enter, select this person's post, which is 190, subtracting from their pre, and this person got the same weight from pre to post, which makes sense. It's a control group in this example, so there wouldn't expect that much of a change, really. Same thing, I can click on this little square right here when it goes to the black cross or plus sign. Click and drag, and it's going to apply the formula to each of those cells just like that. So you can see that these scores, these numbers are coming from that right there. Okay? Okay, so now what we're going to do is we're going to run an independent t-test on these gain scores. So the gain score for experimental, gain score for control. What it's going to do is, when you run an independent samples t-test, it's going to give us the average. So what's telling us is it's going to calculate the average gain score. In other words, it's going to calculate the average amount of change from pre to post for each group. And then we can compare those two numbers to see, hey, is the average change score for the experimental group, is that different or statistically different from our control group? Okay, so let's run that analysis real quick to kind of show you what that looks like. So I'm going to click on the data heading here. Okay, here's the data analysis section. Click on it. And now, instead of doing a paired t-test, now I'm going to do just a regular t-test, 2 sample, assuming equal variance, just like from assignment 3. Okay, same test as before. Click OK. All right, now I got to select my data. So variable 1, I'm going to click on this button here, and I'm going to select my data. So these are the gain scores for the experimental group. Type enter. Okay, now I'm going to click on this button. This will allow me to select my second variable. It's going to be the control group's gain scores push enter. Okay, I have labels checked because I included that whenever I click and drag the numbers. Alpha set at 0.05. And for my output, I want to come, I'm going to click on this button here. Let's have my output come out in that cell right here. Okay, press enter, comes back. Now I'm ready to go. So I'm going to press OK. All right, and there's my output. Same thing, I know I'm weird. I'm just going to put this up here. That way, that makes, there you go. It looks better to me. Okay, so this is our output. And now we have some mean scores here. Okay, so we got a mean of 16 in one of the groups and a mean of 0 in the other. Well, here's one thing to remember. These means, like, are mean, they're something different. Okay, so this mean is the average. This is the average amount of change. Because remember, we're not looking at the raw data. We're not looking at the actual weights. We're looking at what was the change for pre to post. So it's basically calculating a mean score for the change. In other words, what was the average change from pre to post, which is what these numbers represent. So this t-test is running off the gain scores and not the raw data. So we have to interpret it a little bit different for the means, just kind of FYI there. That's why the mean is 16. So that means that the average amount of change in these scores was 16. The 0 here, that means that if you look at if we took an average of these gain scores, they were 0. That's what it is. So that's where those numbers come from. Now let me show you then kind of how you would write this up, and we'll interpret the results of the test. So I'm gonna move this over just a little bit. Okay. All right. So now I'm going to move this over. Scroll down, and this is now the results that you would write for the gain score analysis. So this first part here, this first paragraph, that is the exact same as the last example. You just copy and pasted, because all this is again just the descriptive statistics like age, height, weight, so forth. So that part hasn't changed. Down here, and this is why I've kind of highlighted this, is where we're talking about the gain score analysis. And so let's start off here first by looking at this first sentence, and this is just telling us, again, just kind of what we did. So a gain score analysis was conducted to compare the experimental and control groups on the average change in their 1RM deadlift over time. And then this next sentence tells us a little bit more specifically about what was done. So we took the deadlift scores, we subtracted post-test from pre-test, and those were analyzed using an independent samples t-test, which was this output right here. With the treatment group as the independent variable. And that just means that we use the experimental and control. And from here, this is where we start with our results, like before. But again, with the pair t-test, that can only look at each group one at a time. So just looking at experimental, and then another test just looking at control. What this lets us do is to compare the average amount of change in experimental and in control, and is that different? Is that average change different? So let's read it here. We have the increase in 1RM deadlift was significantly greater for the experimental group than the control group. Well, how do we know that? Well, let's look at the numbers real quick. So right here, I have the mean of 16. So for experimental group, the average amount of change was 16 pounds. Which I got from right here. Standard deviation was 7.4. And again, we followed the same step as before to figure that out. Type in equal sign, SQRT for square root, open parentheses, click on this cell, enter, and 7.4. Because again, standard deviation is just the square root of variance. So these numbers here are saying that they are significantly greater than the control group. So the average amount of change in the control group was 0 pounds. So if I were to take an average of these scores here, the average would be 0. Which we did, and it's found right here. So I just plugged in that number right there. Standard deviation, 6.7. Again, all I did was do square root of this number, and that's our standard deviation. And then this is the results of our independent sample t-test, which can be found right here. And again, you're just plugging in numbers. So the 18, that's degrees of freedom, found right here. You don't need to know what that means right now. That's okay. Our t-statistic, which that tells us kind of, how big is the effect that we're seeing in a sense. We have right here, which is 5.1. Plug that in right here. And then when you look at the p-value, and that's this number right here. And if I were to change this to a number and then pull this out, we can see more easily that the p-value for a one-tailed test is 0.0000. We got a 3 right there. Obviously much smaller than 0.05. So to report that, you can just put p is equals less than 0.001. You don't need to put out that many zeros. Just do that right there. That tells us that the results were significant. So in other words, the average amount of change in the experimental group, or pre to post, was significantly different from the control group. In this case, we know that the experimental group was higher because we have the mean scores right here. 16 is greater than 0. So we know that increased. Then we just have our concluding statement right here, which says that these results indicate that the average change for 1RM deadlift from the beginning to the end of the study was significantly greater for the experimental group than the control group. And there you go. That's an easy way to be able to use pre and post data and to determine was one group significantly different from the other. Whereas with the paired t-test, you can't do that. So that's one limitation of the analysis that's in the textbook. And because that's the only longitudinal analysis that we have in the textbook, that's kind of what we usually have to kind of rely on. But this is a way to kind of get at a research question that chances are most of you are probably more interested in looking at, hey, is there differences across groups over time? And this gain score analysis will let you do that. So the easy example here is when you make your fake data, you can construct it in such a way that you get a similar result like this, or something that kind of matches more of what you would expect to see. But you can follow these same steps. Subtract post from pre, get your gain score, and then run an independent samples t-test on this gain score and this gain score. And then you can use this framework of the results to then write your results, and then you'd have kind of this overarching sentence here at the end that kind of concludes what it is that you found. What all these numbers mean. So hopefully that helps. Hopefully it gives you another option to kind of better get at kind of something you might be interested in, even though it's not necessarily part of the class itself. If you have questions though, please feel free to reach out to your instructor, and I hope you all have a great day.